Okay, before we do what we're going to do today, we're just going to look back at this last question that we stopped on yesterday, because this is how we answered B is kind of the kinds of questions that we're going to look at today. This question, one thing that it made it different from the other ones that we did is they were giving us water is being pumped into an underground tank and it's leaking out of the tank at the same time. So instead of just people coming into a theater, we are having a rate that's going in and a rate that is coming out. Okay, and so we had a rate, our rate in was 8 gallons per minute. Our rate out was this this function here. And so when we got to here and we wanted to know how much water there was at 3 minutes, we had to take into account the initial amount, how much leaked out, and how much got poured in. Okay, does that make sense? So what we're looking at today is rate in, rate out. I just wanted to show you that we kind of did one yesterday. All right, and then we're just going to look how to put all this stuff together. Let's see, this was on page 73, which means what we're doing today is go on page 74. And there's not a place for that, but you can write it up there just fine. Okay. All right, so rate in, rate out. One of the most common and important applications for the definite integral involves what we call rate in, rate out. Okay, these problems are contextual, which means they're like real-world problems that involve multiple moving parts. Okay, so here's your big idea number one. Integrating rates gives you total change. Okay, if I integrate the rate at which water is flowing in, then I'm going to, from 0 to 5 or whatever, then I'm going to get how much water flowed in from 0 to 5. Okay, that's how we get that with the integral. Finding a final value of a function requires integration when a rate or a derivative is given. Okay, and so we have our final value. This is our given or our initial, our starting value, like we just looked at on the question we did yesterday. We add in the amount added and we subtract out the amount that we lost. Rate in, rate out. So this is what it looks like. Final amount equals the initial amount plus the rate, the integration of the rate in minus the integration of rate out. By the way, because I feel like we haven't looked at it too terribly much, when the letters are here, instead of where we've been writing them, it means the exact same thing. It's just a different form of doing an integral, but it doesn't change anything. And then this is another way to look at it here. Okay, so it's pretty straightforward. Initial, rate in, rate out. That's it. But this is critical. Most AP problems start by giving a rate question. Then they will ask you to find an amount at a given time. To do this, we will use the above formula many different situations. Okay, but you will see this type of thing for sure. Okay, so when we are given a rate, so a derivative basically, given a rate and asked for a value, we will use the above formula in some way, which still, this all still comes from the fundamental theorem of calculus. We're just adding a second rate in there. That's all that's happening. Okay, so let's look at this first example here. At 9 a.m., which we look at as t equals 0, Indianapolis Metropolitan Airport has 1,350 people in it. Okay? And for the t being between 0 and 12 hours, people are entering at a rate of e of t. During the same time interval, people leave at L of t. These are both measured in people per hour. Okay, so before I do anything else, I've got some information. I want to notate what I know, and so I can use this for some stuff. If I have a t equals 0, that is my x value. What is the y value when t equals 0? 1350. Is it time t? Because if this is in people per hours, then this is t equals 0. I got 1,350 people. Okay. Then I have e of t. This is my rate in, because that's how they are entering. And then I have L of t. That is my rate out. Okay. So I want to know how many people enter the airport between 12 p.m. and 5 p.m. Okay, and it's just asking how many people enter. It's not asking how many people are in there, not how many people are leaving, how many people enter between 12 and 5 p.m. So does that mean t equals 12 and t equals 5? No. But I need to know what t equals for these. The best and most accurate way to do it is count it on your fingers, right? T equals 0 is 9 a.m. So 12 would be, we go 10, 11, 12. That's 3. And then 1, 2, 3, 4, 5. This would give me what? 8, because it would be 5 more. Everybody okay with that? If I want to know how many people entered the airport between 12 and 5, what do I do? I'm going to integrate what? E of t. So I'm going to integrate E of t dt. Notation is so super important. We cannot get sloppy with that. And then we're doing that from 3 to 8. Okay. Everybody okay with that? Now we want to know how many people are in the airport at 4 p.m. If I want to know how many people are in the airport at 4 p.m., I have to take into consideration a few things. How many people did we start with? How many people showed up? And how many people left, right? So if I want to know how many people are in there, I'm going to take my initial amount. So if I'm looking for, I guess it's A of t, right? What is my initial amount? 1350. Be 1350. Then I'm going to add to it how many people came into the airport. So I'm going to integrate from what to what? 0 to 7. Where'd you get 7 from? At 4 p.m. Exactly. Because if it was 8 at 5, it's going to be 7 at 4, right? And then, so I'm adding the people entering. And then I'm going to subtract the integral from what to what? 0 to 7 again. Of what? L of t dt. Everybody okay with that? All right. Now I want an equation for the amount of people at any time t between 0 and 12 hours. Okay? Any time t. So A of t, I'm still gonna have to take into account my initial amount, right? That 1350. And then I'm going to add to that the people that came in, right? So I'm going to add to that, and I'm going to integrate. Now, here's where we have to be careful, because it's any time t from 0 to 12. So I'm going to go from 0 to t. Okay? Because I can put, then t can be anything from 0 to 12. You okay with that? When I do that, I cannot write this exact thing right here. I have to write e of x dx. And honestly, that variable could be anything as long as it's not t. This is what's called a dummy variable. Dummy variable. And it can't be t because this is t. And that's something that you can get nailed on. So remember when we had integrals defined by functions, or functions defined by integrals. And so if I integrated and then took the derivative, I'm basically just substituting the t in there. Well, if t becomes 5, then that's fine, but I can't put a t here and a t here. Okay, so just might as well use x. Or if you're using x up here, it has to be something else. But it told us we're supposed to be using t. Okay, does that make sense? And that part's a little weird, I know. And then we're going to subtract out and we're going from 0 to t again, so this has to be L of x dx. What questions do you have? Anything? No? Okay, I'll flip it over. Okay. On Monday morning, for t being between 0 and 8 hours, Mr. Passwater receives emails in his inbox at a rate modeled by the function I of t, probably for n, right? The inbox. And that's emails per hour. During this same time, he is deleting emails in his box at a rate modeled by function d of t. It's time t equals 1. Mr. Passwater has 159 emails in his inbox. All right, we understand? Now, we don't even have an actual function. We have names of functions, but we're not actually integrating anything right now. We're just trying to put all these pieces together. All right, so how many emails are deleted from his inbox? Now, is this a rate in, rate out question, A? No, it's just asking you about how many are deleted, right? So the amount that are deleted, I'm going to integrate from what to what? 0 to 7. D of t, nope, yep, D of t, dt, which is weird. The d's mean different things there. Okay, everybody okay with that? All right, good deal. Then I want to know how many emails are in his box at this time. So it's not how much is being accumulated, whether it's being entered or deleted. It's at a specific time what's happening. Okay, so his emails, what do I have to start with? So our amount, we'll do amount of, I guess A of 8 is really what we're looking for. So what did we start with? 159. So when t equals 1, we have 159, right? So this is the only amount I know, that 159. Then I'm going to add to it the amount that get entered, right? So I'm going to add to it, and I'm going to integrate I of t dt. Am I going from 0 to 8? No, because I don't know how many were in there at time t equals 0, right? I know how much was in there at t equals 1, so I have to go from 1 to 8, because that's the information that I have. Okay? Then I'm going to subtract the integral from 1 to 8 of d of t dt. We good with that? Initial amount, rate in, rate out. Okay? Now it says to write an equation involving one or more integrals that gives the amount of emails in Mr. Passwater's inbox anytime for t for 0 to 12 hours. Okay, so see if you can write something. Model what we did right in the question right before this. So it's pretty much identical to this one, except that we have the t's and you got to make sure there's x's in here, right? Now, this says 0 to 12. But is it okay that we went from 1 to t? Can I still substitute 0 in for t? Yeah, that's basically like having, we have this little graph and here's 1. So this is what we have, but we can always go backwards, right? That's why we did backwards, so that works just fine. So you don't have to have a 0 at the bottom. It has to kind of match with whatever you have here, okay? What questions we got? All right, good deal. Let's look at example 3. For t being between 0 and 5, t equals 0 represents 12 p.m. The rate of people that enter a minor league baseball stadium is modeled by this function. So E for enter, that's good. Starting at 2 p.m., people begin to exit the stadium at the rate modeled by this right here. E prime of t and L prime of t are measured in people per hour. And at 12 p.m., there are 412 people inside the stadium. Okay, so what does t equal at 12 p.m.? 0. So that means that A of 0 is equal to 412. Okay? Everybody okay with that? And I want to know how many people enter the stadium in the first 3 hours. So if I want to know how many people enter the stadium, I'm going to have to integrate E or L? E. E prime of t dt. Now remember, we have an actual function here. I could write this, but I don't have to. It's defined as E prime, so writing that is totally fine, and I don't have to worry about a copy error. Okay? And then I'm integrating from what to what? 0 to 3. Okay. I have, this is a calculator question. I have a function. Let's go to our calculator. 1 for new. Let's add a graph. And we're going to put in E of t, which is 536.5 times e to the negative 0.1t. But we have to use x, right? Okay. And we can't see anything. Can you see anything? I can't either. Is that okay? Probably. We hope, I mean, even if we saw something, we wouldn't necessarily know if it was right, right? So we didn't get an error. I think we're good. So I'm going to add a page. I'll add a calculator. I want to integrate, so I'm going to use my little key there. And I'm integrating from 0 to 3. F1 of x dx. That's what I got. Well, that's a good question. It does not say to round to the nearest person, and so since it doesn't, I would write down both. Or just, honestly, you can leave it as a decimal. I know part of a person doesn't make any sense, but because it doesn't say one way or the other, I would go ahead and write down, well, if I can write it down correctly, 0.510, write down what you got, right? And then you can say that that is, it would be 1,390 people, because, again, you can't have part of a person, fit in there, but I believe on the actual test, it's going to be more specific. It might say to the nearest person or that type of thing. Okay? We all good with that? All right. We got the hang of the calculator on that, right? So how many people are inside the stadium at time t equals 4? So that's going to be our rate in, rate out, right? It also might be a good idea to mark here that you put like E prime of t, or maybe mark it up here somewhere, put that this is in F1, because we're going to put the other one in there too, and then you know which is which. All right, so I want to know how many people are inside the stadium at time t equals 4. So that means I want the amount at 4. What is the first thing I write down? What's the initial amount? 412. 412 plus the amount of people that entered, our rate n. So I'm going to integrate e prime of t dt from 0 to 4. They didn't give us a time, so we didn't have to figure that out, right? And then I'm going to subtract the amount of people that left. So I'm going to integrate L prime, that is an L, right? Yeah, L prime of t dt. Now, my limits of integration, not 0 to 4. Why do you think they wouldn't be 0 to 4? Because it's, yeah, nobody's leaving until 2 p.m., right? And at 2 p.m., t equals what? 2, okay? So I don't get to start this until 2, so I'm going, this is going from 2 to 4. So sometimes those two don't match, right? Kind of depends on, it's like filling up the bathtub and it's halfway full, then you pull the drain, right? It doesn't start until then. All right, everybody good with the equation? Okay, so now we go back to our calculator. We're going to go back to the graph. So control arrow gets you back there. How do we get back to be able to type something in? Tab. Oh, ooh, 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 my tab is dancing. Okay. And I can't read mine because I have something written on it. And I don't know where to do with the extra one. Okay, well, I lost all of those, so. Oh my gosh, stop dancing. Maybe if I start typing. It looks like 398. There we go. 398 times the sine of, I can't tell what's in the numerator. Is that pi times x? Okay, I can't read it on mine. Pi times x over 5. That looks crazy, right? Is that what y'all got, though? So at least we all match. You know, again, I know by seeing that, you don't know if you're right or not, and that's okay. We don't really care about what it looks like. I'm going to go back to my calculator, and then we're going to type in everything we just wrote. 412 plus the integral from 0 to 4. And that first one, that is f1 of x dx. Then we're going to subtract, nope, not like that, minus, then I got to get my integral again. If you get stuck on any of the calculator stuff, let me know. 1 to 2 to 4. No, not there. 2 to 4. I wish I could just use a real calculator and project it up here. Is this F1? This is F2 of x dx. Okay, everybody agree with that? Is that the number you got? Good deal. Anybody need calculator assistance? Okay. And I wrote ginormous, apparently, because I ran out of room. This is equal to 1472.529, which is 1,472 people. This question, not this actual question, but a question was asked in one of the forums I'm in for this AP stuff, and they were asking about these people questions, and then people were fighting about, whether we round up or we round down or what, have the 3 decimal places. I don't think anybody's going to, harm you either way on that. Okay, what questions we got? All righty. Now we're looking at one. We're going to write an expression involving one or more integrals that gives the number of people in the stadium at time t. Write it out. I bet you can do it. We good? What questions you got? All right, y'all are awesome. All right, let me give you page 2, which is technically your assignment. We're going to do one together, so you can whine all you want. I'll just make you do it all by yourself. Okie dokie. You can also put this on 73. Yes. It's 74. That would make more sense. Thank you. Okay. A small car dealership in Lebanon has 29 cars on the lot at time t equals 0. During the time interval from 0 to 20, new cars are added. Here's the rate in, right? New cars are added. This is rate in. They're removed from the lot. At this rate, this is our rate out. Okay. Our amount at time 0 is 29. So that's our initial amount, right? A asks, is the amount of cars on the lot increasing or decreasing at time t equals 11, and explain your reasoning. So it's not asking me how many, not asking me how many came in, how many left, or how many's on there, but is the amount of cars on the lot increasing or decreasing at this time? So what kind of information do you think would help us figure that out? What would it mean if the amount of cars on the lot is increasing? What would that tell you about how these two would be related at that time? That more coming in. Exactly. Rate in would be bigger than the rate out if the amount is increasing, right? If the amount is decreasing, then less are coming in than are leaving, right? So that means what I actually want to know, excuse me, are the actual rates. Excuse me. In order for me to figure out the rate in at t equals 11, do I need to integrate anything? I just need n of 11, right? I'm not actually going to integrate that. I also need s of 11, but I'm not actually going to integrate it. I'm literally just figuring out what the answer is, right? Just substituting it in. So let's put this one in F1. Let's put this one in F2. And so since we're on a new question, get a whole new everything. Don't just delete it out. Just say no and start back over. Add a graph. All right, so negative. I think that's right. I don't know about you, but I can't see either one. I'm going to add a calculator. Do y'all have them typed in? So if I just want n of 11, what do I do on this screen? F1 of 11. Boom. And then F2 of 11. that what y'all got? Okay, good deal. So then on my paper, on my paper, I need to actually write those down. We got 8.822 and 6.823. And look, it says right here, this is cars per day. Cars per day. This is cars per day. Okay, so on day 11, is the amount of cars increasing or decreasing? Increasing because this is greater, right? So we can say the amount of cars, on the lot is increasing at t equals 11 days. Don't leave off your units on that. 11 days, because n of 11 is greater than s of 11. Almost right, s. Okay? And then we didn't write, that's good enough, but we also do need to put those units on that, and that's cars per day. I mean, you could write, because the rate the cars are entering the lot is greater than the rate that they're exiting, but that's a lot of stuff. You doing that, that's good enough because it's all defined. Okay? What questions do you have? All right, so we're going to skip over this one because that's like the same thing that we had been doing with the rate and rate out. I think you kind of got that. We're going to go to C. Same question, but this says at what time t, for t being between 0 and 20, is the amount of cars on the lot a maximum? And justify your answer. Okay, if I want to figure out when it is a maximum, what do we do to figure out our maximums and minimums? Do you remember what we had to find? The what? The sign chart, okay? That works, right? And in order to do a sign chart, I have to know the derivative, right? And what do I do with the derivative to figure out what to put on my sign chart? Yes, there's a test that goes with it. But in order for me to get that far, the sign chart and the test, what do I do with the derivative so I can figure out what numbers to test and what numbers to put on my sign chart? The zeros, right? You gotta find the zeros. Okay. So I want the amount of cars. So the amount of cars, I'm calling that A of t. If I want to know when it's a maximum, I need to find when A prime of t equals 0, right? So how can I set something up? When would the change in the amount of cars, because that's what that is, right? The change in the total change in the number of cars, when would that be at 0 in general? What would have to be true about these two rates? This would be bigger. If the total change is 0, can one be bigger than the other? They have to be the same, right? If they're the same, if 5 cars come in and 5 cars go out, then the amount of cars did not change, right? So when the rates are equal, that's when A prime of t equals 0. Does that make sense to you? So that means that this, what I need, in order to get this, I need n of t to be equal to s of t. I do that, and then I find those zeros, all right? Now, you mentioned sign chart, which we absolutely did with maximums. The sign chart gives us relative maximums and minimums. And even though this doesn't state whether it's a relative or a global or that type of maximum, it just says maximum, then we assume that it's going to be the absolute or the global. So that's not, so our sign chart will tell us where we could have a couple, but then you said, I heard some sort of test. Do you remember a test that we did? Candidates test? Okay. So with the candidates test, I had to have t and A of t, right? Now we're basically just going to set this up and talk about it so we can talk about something else. But in your candidates test, what do you know for sure is going to go in this chart? 0 and 20, right? Those are for sure. And then any zeros. And so how are we going to figure out where n of t equals s of t? Well, whatever a prime of t equals 0, but we don't have an a or an a prime, right? But did we graph these? Yes, we did. So let's go back and look at our graphs, see if we can see anything in our, oh, we can't see anything, right? Oh, darn. Okay, but do we know what our x values are supposed to be? They're between 0 and 20, right? Okay, so they're between 0 and 20, so let's go and fix that. So menu, window settings, x, we're going to go from 0 to 20. All right, and then let's hit enter and let's just see, oh, now I see something, right? So do you think that I need to care about anything down here? No. So let's go back and we can do that again. Window 1. And so the 0 and 20 are fine, but I'm going to make my y minimum 0. And let's just make this 20 and see what happens. Oh, look at that. Okay. Now, where do these two functions equal? Right there, right? How do I figure out where right there is? Good. Menu, analyze graph, intersection. Move, well, it's already to the left of it, so I'm good. And then I move it to the other side. I'm good. And there's my intersection. Am I interested in the x value or the y value? The x value. And that's not a pretty value, right? So I need to do what with it? Store it. So I'm going to hover over it. Looks like I'm about to grab it. Then what do? What do I do to store it? Variable, yeah. What? And then what do you want to call it? B? Is that what you said? Okay, sure. We'll call it B. That's fine. Totally fine. You can call it whatever you want. Just make sure you know what you called it. And so over here, I'm going to put, this is B equals 14 point something, right? Dot, dot, dot. And then we would go from there. Okay? We all okay so far? All right. And we don't have time to do the rest, but I at least wanted to get it set up. But because I wanted you to think through how you know to set things like this up and remember the candidates test and all that kind of thing. We good? Awesome.